All right, so we're up to lesson 20. This says lesson 18 homework, but it's really lesson 19 homework. So again, we're not here to talk about it because you're watching the video, but if you have questions, you can email me, talk to your friends, check out office hours, whatever you're looking for. And of course, I strongly suggest that you do stop and start until you follow all the steps and everything's good. So I'll quickly go through this, but you're going to stop and start on your end so you can check out everything thoroughly. Don't mind my dogs barking. Okay, so that is, or those are the answers to the homework. Next up, the pregame stretch. Go ahead, start it up. Lesson 20, pregame stretch. Okay, remember you're doing stop and start here. Okay, so now let's check the answers out to that pregame stretch. And they're right here. There you go. Just as before, if you have any questions, you can email me and I'll get in touch with you. We can set up office hours to go over it. You can talk to your classmates, whatever works best for you. We will find a way to make happen. Again, stop and start as needed. Remember, factor completely means 2 steps or more, possibly. I wonder if there's another page of this, because it seems to run short here on number 14. And we had some more questions after that. Let's see what this looks like. Yep, there we go. Okay, so we are now done with all of that. It's time to get started on today's PowerPoint. Okay, so let's see if I have to swap displays. Let's see, a slideshow, play from start. Okay, boy, oh boy. Oh man, I think I have to swap displays. So I'm going to go with that. I hope I'm not wrong, but usually I have a laptop and I also have a monitor screen. Usually what's ever on the monitor screen is the right thing to have. Not 100% of the time, but probably 85 or 90% of the time. And right now it's up on the monitor as a full slide, so I think this is the right way to do it. I hope so. I realize every now and then it doesn't work, and I do not know why. Okay, so exploring exponential functions, lesson number 19. Let's get cracking here. We have done the homework review. We've done the pregame stretch completely. Let's recap some recent work. Go ahead, factor completely. You'll notice they're getting less and less of these guys. And of course, you're doing stop and start, so it doesn't take so long on my end. Okay, for the first one, they share a 4 in common. Oh, God. I have no idea why that says a 3 there. X squared plus 4x minus... My only guess is it didn't save from the last time. 21. And this would be x plus 7. X minus 3. And as I peek ahead at the others, they seem to look good. X minus 3. So let's go play from current slide. I think we're pretty good. Okay, so here's the first one. Oh, that should be a 4 underneath there. I didn't change that. Let's do fix. Okay, so play from current slide. Here we have the right answer. Okay, so they shared a 4 in common. I factored it out. I come up with x squared plus 4x minus 21. And then I have to factor the remaining trinomial into x plus 7 times x minus 3. Next one, they share an x in common. Then I break down the difference of two perfect squares. X squared minus 9 is x minus 3x plus 3. And then 16x to the fourth minus 625 is 4x squared plus 25, 4x squared minus 25. And then I can factor that to 4x squared plus 25, not 9. Obviously, some of these things didn't save from last week. And then 2x plus 5, 2x minus 5. Okay, go ahead. Solve for all values of x. Don't forget, stop and start. Okay, so x times x plus 1 is going to equal 72 after we cross multiply. Distributing the x, it's x squared plus x is 72. Subtracting it to get it all on one side, x squared plus x minus 72 is equal to 0. Factor x plus 9, x minus 8. Maybe it's the guy on the left, maybe it's the guy on the right. X is negative 9, x is 8. Okay, next up, a rectangular piano measures 6 meters by 8 meters. It's to be increased to an area of 88 square meters. We've done ones like this before. This is probably the last time you'll see this before a possible pretest question. So, go to it. Okay, we're increasing each side by the same amount, which we're going to call x. That makes the length of one side x plus 8, the length of the other new side x plus 6. If I multiply them, I get 88. So that's x squared plus 14x plus 48. When I distribute the two binomials, double distribute. Subtracting the 88, I get minus 40. And you get the hint here when it says to the nearest tenth that you're going to need the quadratic formula. So don't waste time trying to factor the thing. And that'll give me a is 1 because that's in front of x squared. B is whatever's in front of x, which is 14, and C is the number at the end, negative 40. There's my formula. Substituting in, x is equal to negative 14, plus or minus the square root of 14 squared minus 4 times 1 times negative 40 over 2 times 1. Crank out those numbers, I get 196 plus 160, which is 356, and the square root of that is approximately 18.9. So one cool thing here is the next step is negative 14 plus 18.9, which is 4.9 over 2. And the other one's negative 14 minus 18.9. And that's impossible because we can't have a negative length. So we can just ignore that. So 4.9 over 2 is 2.45. It wants to the nearest tenth, so we're going to go with 2.5. Okay? All right. Write the inverse function. Go ahead. Okay, always doing this stop and start stuff. Switch the x and y, solve for y. X equals 3y plus 27. That's the switching. Now the solving, minus the 27, dividing by 3, and I get x over 3 minus 9 equals y. Next up, y equals 4x squared minus 5. Switch the x and y, solve for y. Add 5, divide by 4. For some reason I copied the 3 down here. It should have been a 4, but I corrected it there. Square root both sides. And I get y equals the square root of x plus 5 over 4. All right, so again, this is all review, stuff that we should be pretty comfortable with, but if not, we're cleaning it up a little bit, get one last shot to come in here and get it looking good. Okay, so we can evaluate each of these one at a time, or we can do all the ones in the left by using the y equals function on our calculator, and then looking for the corresponding value in the table, and also for the one on the right. Now, to be honest with you, the one on the left is easy enough that you can probably do a lot of it in your head. The one on the right, I think the table is very helpful with. Go ahead, do them both. Okay, so for the first one, f of 9, it's going to be 7 times 9 minus 4, which is 63 minus 4. 63 minus 4 is 59, not 57. Don't know why it says it there. When this happens, it just doesn't save things. Next one, 7 times negative 3 is negative 21, minus 4 is negative 25. And then 7 times 11, 77, minus 4 is 73. Next, I might have to sneeze soon. Again, excuse me. Excuse me. I would have done this one using the y equals function on your calculator. 3 times negative 4 squared is 3 times 16, which is 48, minus 4 is 44. 3 times 9 squared is 3 times 81, which is 243, plus 9 is 252. And negative 7 squared is 49. 3 times 49 is 157, minus 7 is 150. Okay. Here's another one where multiple times it doesn't always save when it says to save. So a lot of times the last two were already on the screen for you. Now they're not, because this one finally did save correctly. Okay, answer these 4. Go ahead. You know the deal with the stop and start. Okay. Now, f of g of 4. Remember, we read this backwards. I'm sorry, it says g of f of 4. So the first thing I did was find f of 4, substituting in 4. 3 times 4 is 12, plus 5 is 17. And then g takes whatever you give it, whatever the input is, and it squares that input. So 17 squared is 289. Next one, g of 4, then find f of it. So I put a 4 into g, square that. That gets me 16. And then I hand a 16 to f. 3 times 16 is 48, plus 4 is 52. Okay, now, these composition written this way, remember we read right to left. First I find f of x, and in this particular case, we want to interpret this as I specifically give it the letter x. That's my input. And if I do, my output is 3 times that very same input x, plus 5. Then that in turn has to get passed to g, which squares anything. And that means 3x plus 5 squared, which is 3x plus 5 times 3x plus 5. And you double distribute. Don't go giving me 9x squared plus 25. That's not what 3x plus 5 is. 3x plus 5 squared means 3x plus 5 times 3x plus 5. And when you do that, you will get 9x squared plus 30x plus 25. Next one, f of g of x. So now we give g the very specific input of an x, and it gives me the output of that same x input as x squared. Then x squared is passed into the f of x function, and that's 3 times what you gave it, which is 3x squared plus 5. Okay. Now, just a reminder on what is and is not a function. The first one is a function because each of the domain elements in the table has one and only one image. I don't care that 2 of them go to 17. That makes no difference to me at all. I just care that you don't like get 2 going off from any one input value, or 2 outputs from one input value. Here's an example of not a function and what I mean. This is not a function because of the 3. I don't care about the 17. I care that 3 goes to both negative 3 and 17. That's not allowed. That's a relation. It's not a function. So take a look at the next 2. See if you think they're functions or not. Okay, this first one, it is a function because 1 only has one image, 2 only has an image. I don't care that they're both 5, irrelevant to me. 3 and 7 both have 9 as their images, but Each one only has one image. That's perfect. The last one is not a function. 1 goes to 8, and 1 also goes to 9. That can't be, not in a function. 3 goes to -9, 3 goes to 21. That can't be, not in a function. Okay. Radical equations. Go ahead, solve all 4 of them. Okay. So we've done our stop and start. It's isolate the radical, which in these cases they are both already isolated, and then square both sides. So first one, I square both sides and I get x is equal to 121, because the square root of x squared is x. Because squaring is the inverse of square rooting. They undo each other, so to speak. And 11 squared just means 11 times 11, which is 121. Next one, square both sides. If I square the square root of 2x minus 3, I get 2x minus 3, and 7 squared is 49. Just solve it. Add 3, divide by 2, x is 26. Next one, it's already isolated, the radical, square both sides. 3x minus 6, the square root of that squared is just 3x minus 6, and then 3 squared is 9. So 3x minus 6 is 9, add 6, divide by 3, x is equal to 5. Okay, next up, square both sides, and I get x squared equals 2x plus 5, and 35, I'm sorry. Get it all on one side, x squared minus 2x minus 35 is 0. Factor, maybe it's the guy on the left, maybe it's the guy on the right. I get x is 7. And then we get to reinforce that concept of an extraneous root. X does not equal -5. The reason it does not equal -5 is because if I try to check that -5, it won't check. A square root, unless you put a negative in front of a square roots are always positive. So when it says -5 equals the square root of something, that cannot be, because there's no negative in front of that square root. So it does not check. Okay. Consecutive integers problem with the brothers. Go ahead. Okay, so in this particular problem, there were brothers with consecutive even integers, so those are n plus 2, and n plus 4. Now, a lot of times students get lost in word problems because they kind of look at the whole thing and there's so much there that it overwhelms them. Instead, break it down and write pieces. So the pieces that I would write would be the product of the first and the third is 116 more than twice the second brother's age. Now, what's the first and the third? It's n and n plus 4. So there's your product. N times n plus 4 is 116 more than, last shall be first, first shall be last, twice the second brother's age. Second brother is n plus 2. So distributing, I get n squared plus 4n equals, distributing on the other side, 2n plus 4 plus 116. Cleaning it up a little bit, and I get n squared plus 4n equals 2n plus 120. Subtracting the 2n and the 120, and I get n squared plus 2n minus 120 equals 0. Factoring that, you might get a little intimidated by the 120, but it's not bad. It's 12 and 10. Maybe it's the guy on the left, maybe it's the guy on the right. So that works out to be -12 and 10, but -12 can't possibly be an age, right? So that's an extraneous root of sorts. So it doesn't fit the criteria. 10 is the correct answer. So the three brothers are 10, 12, and 14. Okay. All right, go ahead. Let's find f of g of 5 using those functions. All right, so first, remember you read this backwards here, right? So I'm going to do g of 5 first. If I give a 5 to g, it's 5 squared minus 1, which is 25 minus 1, which makes 24. Then that output has to become the input for f, and that becomes 3 times 24 plus 1, which is going to be 73. Okay, next up. Okay, so I have to substitute in the x as the specific input for g. So if I do that, I give x specifically to g, I get 3 times that x plus 5. So that's the output. That in turn gets shuffled into the f problem. So the output of g is 3x plus 5. That is given to f, which takes whatever the input is, and it doubles that input. That's what 2x means, then minus 1. So I got to do 2 times 3x plus 5 minus 1, which is 6x plus 10 minus 1, which is 6x plus 9. Bingo, choice 3. Okay, next one. The accompanying graph shows the curves of best fit for data points comparing temperature to altitude in 4 different regions represented by the relations A, B, C, and D, which is not a function. Go ahead. Okay, I'm assuming you're doing stop and start. The one that's not a function is A, because it fails the vertical line test. We spoke of the vertical line test before and what it means, though we haven't drilled it as hard as we could have. What it basically means is anytime you draw a vertical line through what you think is a function, if it only touches once at every point along the x-axis, then it is a function. But if at any point, or more than one point, it touches twice, it's not a function, because that means one input, an x value, would have 2 different outputs. That is 2 different y values. That's not allowed. So here, right in this section of A, right in here, if you draw a vertical line, it's going to touch twice. So that's not a function. Okay. All right, let's do another literal equation type of question where we solve for R in terms of F, G, M1, M sub 1, and M sub 2. Go ahead. Okay, so one way to attack this is to cross multiply it. So I just put the f over 1, cross multiply, and I get fr squared equals g m sub 1 m sub 2. Now I want to solve for r, which means get r all by itself. And the first thing that's bad is that f, so I divide both sides by f. And that gives me r squared equals g, which is actually the force of gravity, times the mass 1, the mass of the first object, the mass of the second object, divided by what the force is. And then if I square root both sides, I get the radius is the square root of that gravitational constant g times the mass of the first object times the mass of the second object divided by what the force was. All right, so what I'm going to do at this point is stop the first video, even though we're going to review some fractional and negative exponents, but I'll include that as part of the next video because I believe we only have about 9 slides to go after this one, and I want to try to balance the videos a little bit more.